Alright, sixth graders, welcome back. Today what we're going to be looking at is the Pythagorean theorem. And this is also on page 450. So you maybe want to follow along with me as I go through some of the examples for this. Now the Pythagorean theorem has to do with triangles, and it has to do only with right triangles. So if you draw a right triangle, I'm going to show the right angle symbol. We have what are called legs and we have what are called hypotenuses. And the legs are always the ones touching the right angle. So these two are also the legs, or in our formula they're going to be A and B, and it doesn't matter if they are switched around, but they're always touching the right angle. The one opposite the right angle is what is called the hypotenuse. Okay, and the hypotenuse is always going to be the longest side. So you can know that, if the legs are 10 and 12, the hypotenuse has to be larger than 12. So that's kind of always a way to double check your answers. And what we're using today, guys, is called the Pythagorean theorem, and what it is this: a squared plus b squared equals c squared. So you can use this to find a missing side. So if the legs are missing or if the hypotenuse is missing, you can use this Pythagorean theorem to find that missing side. So we are going to try a few. So go ahead, draw a right triangle. It has one right angle. And this is going to be a scalene right triangle. So I'm going to draw a right side there. We're going to label the legs 12 inches and 16 inches. And those are the legs again because they're touching the right angle. We don't know what the hypotenuse is right now, so it doesn't matter what variable you plug in there. So we're going to plug in what we know to the formula here. Remember, A and B are always the legs and C is the hypotenuse. So we know both the legs. We can plug them in for A and B, and it doesn't matter which one's which. So we know 12 squared plus the other leg is 16 squared, and we don't know the hypotenuse. So go ahead and try this math. 12 times 12, not 12 times 2 again. Okay. Should be left with that. Try 16 squared. You should get 256. Go ahead and add the two together to see what you got so far. You got 400, and that is equal to c squared. Well, for our triangle, guys, we don't want c squared. We want to just know what c is. So kind of like when you're solving SADMET problems, when we had an addition, to get rid of it, we did subtraction. Or when we had multiplication, to get rid of it, we did division. The same is true for this squared. To get rid of a square, this is the opposite, kind of like when we did our perfect squares chart. So to get rid of the squares, we can do the square root. Remember, on stupid line problems, what we do to the one side, we have to do to the other. Okay, so these kind of cancel each other out. So now we have C, and you can use this on your calculator. Find the square root button, and you type, depending on your calculator, sometimes you type the square root button in first, and then you type in 400. This goes a little bit above our perfect squares chart to see what we have left, but you should be left with 20. Okay, so the hypotenuse is 20, and our label is inches. And this answer, we can check, makes sense because it is longer than the legs. It is longer than 16 inches. So that's a reasonable answer. Sometimes they don't always come out to a whole number, but you can use your calculator for finding the square root on these kind of problems. We're going to try one more of using the Pythagorean theorem here, and this still goes with example 1 if you're looking in your book. So go ahead, draw a right triangle again. I'm going to draw the right angle, and let's label, one of the legs 15 meters. Let's label the hypotenuse 17 meters. So again, that's the one across from the right angle. This time, we don't know this leg. So again, I always start off by writing the Pythagorean theorem, a squared plus b squared equals c squared. And now we're going to plug in what we know. This time we only know one of the legs. So it doesn't matter if you plug it in for a or b, but we're still going to have a variable on this side. Whoops, there it went. And this time we know the hypotenuse, so we're going to plug it in for c. Okay, so we have the variable on this side this time. So go ahead, solve this math. 15 times 15, or 15 squared. I got 225. And try 17 squared. And I got 289. So this is a little bit different than last time when we set this up. You know, we kept solving and we just took the square root. Well, we want to get b squared by itself, so I got to get rid of this 225. So what should we do to both sides to get rid of it? It's a positive 225, so we should subtract 225. Okay, and see what we're left with. I got 64 for that. Okay, now we got the b squared, so kind of like before. To get rid of the square, we take the square root. So we're going to do the same thing here. To get rid of the square, we take the square root. So we know b equals, and you probably recognize that one as a perfect square, is 8. So our final answer is 8 meters. And it's not 8 meters squared because it's just the side of a triangle, not the area or anything. And that makes sense because the hypotenuse has to be the longest side, and that's 17, and 8 is less than 17. So that's always a way to double check. The last one we're going to look at, guys, is like example 2. And this is the baseball diamond one. So we're going to, it says a regulation baseball diamond is a square. So I'm going to draw a baseball diamond, but it's also a square. So all 4 side lengths are the same, and you can do your best at drawing a square. But we know all 4 side lengths are the same. And this is home plate, this is first, this is second, this is third. And again, if you tilted your screen, it should be a square, it says. And it says that sides that measure 90 feet. So we know they're all 90 feet, all the same. About how far is it from home plate to second base? So we're figuring out from home plate here to second place, or second base, sorry. Notice what that forms. You might see it forms a triangle. And we know this is a right angle because it is a square when you tilt it. So we can use the Pythagorean theorem to solve for this. Okay, so we're going to plug in a squared plus b squared equals c squared. And again, if you kind of tilt it, this time they give us both of the legs of the triangle. So we know 90 squared and 90 squared, and we're trying to find the longest side. And without even doing any math, we know it has to be longer than 90 feet. So go ahead and do that math. 90 times 90, 8,100, 8,100. Go ahead, add them. I got 16,200. And we're left with c squared. And again, the last step is to take the square root, take the square root. Oops, I'm trying to get a new page there. So I know I'm left with c equals, and you kind of get a decimal once you try that in your calculator, 127.279. And the directions say round your answer to the nearest tenth. So I'm going to look. Yep, I round up, so I'm left with 127.3. And we were talking about feet for that. So that is my answer, and that makes sense because it is longer than 90 feet. So now you can come ask questions you have for class. We're going to try some problems on your own.